While the silhouette mimics the profile of a Nimitz-class supercarrier, this vessel represents a distinct breed of naval violence, the Wasp-class amphibious assault ship, engineered not merely for air superiority, but for the complex logistics of littoral invasion. It is a floating fortress designed to bridge the gap between sea and shore. The strategic logic is cold and irrefutable. Air power alone can pulverize infrastructure, but it cannot seize territory, enforce curfew, or govern a population. To effectively decapitate a hostile regime and secure the vacuum, you require the physical presence of the United States Marine Corps on the ground. This necessity birthed the LHD, a multi-purpose platform stacking aviation, amphibious assault, and command capabilities into a single 40,000-ton displacement hull. Unlike the singular focus of a carrier, this ship is a Swiss Army knife of power projection, capable of acting as a miniature airfield, a garage, and a hospital. The vessel is organized into 10 primary decks, a vertical city where every square meter is optimized for the storage and deployment of warfighting assets. At the apex sits the superstructure, often called the island, housing the nerve center of the ship, the bridge, and the primary flight control. From the bridge, the officer of the deck manages navigation and ship handling, while Pryfly towers above, orchestrating the dangerous ballet of the flight deck. Below the island lies the flight deck, a flat-top expanse of non-skid steel serving as a forward operating base for short takeoff and vertical landing aircraft. Here, the air wing is not just a defensive measure but an offensive hammer, featuring the F-35B Lightning II, a fifth-generation stealth fighter capable of vertical operation. These jets allow the LHD to function as a lightning carrier, projecting stealth air power into contested zones without the need for a larger nuclear carrier. Alongside the fighters, the deck supports a rotary wing fleet, including MV-22 Ospreys and AH-1Z Vipers, essential for rapid troop insertion and close air support. The flight deck operates in a state of controlled chaos, where fuel lines, ordnance carts, and directing crew members weave between spinning rotors and jet exhaust. Despite the intensity of operations above, the true volume of the ship's aviation capacity is concealed in the cavernous hangar deck immediately below. This protected garage spans the length of the superstructure, shielding high-value aircraft from salt spray, weather, and enemy surveillance while awaiting maintenance. To maximize density, helicopters fold their rotors like origami steel, allowing ground crews to pack airframes inches apart in a display of logistical Tetris. Connectivity between the flight deck and the hangar is maintained by two massive aircraft elevators located on the starboard and port edges of the hull. These hydraulic platforms serve as the ship's arteries, cycling fully loaded aircraft to the launch operational area with rapid, rhythmic efficiency. Descending further into the ship's belly, the architecture shifts from aviation support to heavy ground mechanization, revealing the massive vehicle stowage areas. This deck is the parking garage for the Marine Expeditionary Unit, housing rows of M1A1 Abrams main battle tanks, light armored vehicles, and Humvees. The layout utilizes a complex series of internal ramps and turntables, allowing for the rapid reconfiguration of vehicles based on the specific mission profile. Every vehicle is lashed down with heavy chains to prevent catastrophic shifting during high sea states, waiting in darkness for the call to disembark. The sheer weight of this armored column requires the ship to maintain precise ballast control to prevent listing when heavy armor moves during deployment. Below the vehicle decks lies the defining feature of the amphibious assault ship, the well deck, a cavernous hangar located at the waterline stern. By ballasting down the ship's stern, the crew can flood this bay with seawater, creating an internal harbor for launching amphibious connectors. This capability allows the ship to deploy landing craft air cushion, LCAC, hovercraft directly from the hull while the vessel is still miles offshore. The LCAC is a critical asset, riding on a cushion of air to transport heavy armor like the Abrams tank across water and directly onto the beach. This over-the-horizon assault capability keeps the mothership safely outside the range of most coastal defense artillery while delivering heavy shock forces. Interwoven with these operational decks are the habitation layers, the hotel services that sustain a crew of sailors and a battalion of Marines. The berthing compartments are stacked bunks, maximizing human density to house nearly 2,000 personnel in a confined, air-conditioned ecosystem. Life on board is a cycle of watches, drills, and maintenance, supported by massive galleys, gyms, and even a fully equipped Level 2 trauma hospital. The medical facility is a strategic asset in itself, featuring operating rooms, an ICU, and X-ray labs to treat combat casualties immediately after extraction. This self-sufficiency allows the LHD to operate independently for months, serving as a floating sovereign territory capable of humanitarian aid or total war. Command and control functions are distributed across the 0-2 level and above, ensuring redundancy in case the primary bridge takes a kinetic hit. The bridge itself is a dual-level glass enclosure, providing visibility for navigation and the specialized task of coordinating replenishment at sea. During these underway replenishments, the ship connects via fuel lines and cargo rigs to supply vessels, taking on jet fuel and dry goods while moving at speed. Precision is paramount, as the helmsman must maintain a steady course and speed alongside a tanker, often with less than 50 meters of separation. The captain, or commanding officer, orchestrates this from the bridge, utilizing a deep understanding of hydrodynamics and relative motion to prevent collision. While modern navigation relies on GPS, the crew maintains proficiency in dead reckoning and celestial navigation, fundamental skills rooted in mathematics and geometry. Understanding the physics of the ocean and the geometry of intercept courses is what separates a competent sailor from a liability in high-stakes maneuvering. For those interested in the mathematical foundations that govern such engineering marvels, interactive learning platforms offer a bridge to understanding these complex systems. Mastering concepts like calculus and trigonometry is not just academic. It is the language used to design these hulls and plot their trajectories. Engaging with problem-solving modules helps cultivate the analytical mindset required to command systems as complex as a $2 billion warship. Returning to the engineering, the propulsion of the Wasp class is a study in raw thermal power, originally driven by steam boilers in early hulls. In these steam-powered variants, massive boilers burn fuel to generate high-pressure steam, which is then directed into turbines to drive the twin shafts. However, the evolution of the fleet has seen a transition in later vessels, like the USS Makin Island, toward gas turbine and hybrid electric drive systems. The General Electric LM2500 gas turbines used in modern iterations function similarly to jet engines, compressing air and igniting it to generate rotational force. This shift to gas turbines and hybrid drives significantly reduces fuel consumption and startup times compared to the legacy steam plants of the older ships. Regardless of the power source, the energy is geared down through massive reduction transmissions to turn the propellers at an efficient operational RPM. The reduction gear is a massive, precision-machined component responsible for translating the turbine's high-speed whir into the brute torque needed to push water. By stepping down the rotation speed, the system ensures the propellers bite into the ocean rather than cavitating, maintaining efficient thrust at 3,600 RPM. In hybrid configurations, electric motors can drive the shaft at lower speeds, allowing the gas turbines to shut down completely for fuel-efficient cruising. This propulsion redundancy is critical. If the main engines fail, the electric drive provides enough power to keep the ship steerable and fighting. But engineering is merely the means to an end. The strategic question remains, why build this when the Navy already operates nuclear supercarriers? The answer lies in the fundamental limitation of air power. A fighter jet can destroy a building, but it cannot occupy a city block. A Nimitz-class carrier is a strike weapon, designed to project kinetic energy and dismantle enemy air defenses from hundreds of miles away. However, to actually seize territory, stabilize a region, or prevent an enemy force from reclaiming ground, you need physical boots on the soil. This is the doctrine of sea basing, using the ocean as a maneuver space to insert a self-sustaining ground force where the enemy is weakest. The LHD serves as the delivery mechanism for the Marine Air-Ground Task Force, a unique military formation that integrates air, ground, and logistics elements. While the carrier dominates the blue water, the amphibious assault ship dominates the littorals, the complex coastal zones where sea meets land. In these shallow, congested waters, the ship's ability to multitask becomes its primary weapon, shifting seamlessly from air support to surface assault. The transition from ship to shore is the most vulnerable phase of amphibious warfare, requiring speed and overwhelming violence of action to succeed. Traditional landing craft are slow, vulnerable targets, restricted to landing on the small percentage of the world's beaches that have favorable gradients. To overcome this geographic limitation, the U.S. Navy deploys the LCAC, or Landing Craft Air Cushion, a vehicle that fundamentally changes the mathematics of invasion. The LCAC is not a boat. It is a high-speed hovercraft that rides on a cushion of pressurized air contained within a flexible rubber skirt. Powered by 4 gas turbine engines, similar to those found in aircraft, the LCAC lifts its 60-ton hull completely clear of the water's surface. This air cushion eliminates drag and allows the craft to travel at speeds exceeding 40 knots, leaving traditional landing craft far behind in its wake. More importantly, the LCAC is amphibious in the truest sense. It does not stop at the waterline but continues directly up the beach. It can traverse mudflats, sand dunes, ice, and obstacles up to 4 feet high, penetrating inland to offload armor on firm ground. Image of hovercraft physics diagram. By hovering over the terrain, rather than plowing through it, the LCAC opens up more than 70% of the world's coastlines to assault. This creates a tactical nightmare for the enemy. Instead of defending a few known beaches, they must defend hundreds of miles of accessible coastline. The sheer speed of the LCAC allows the mothership to launch assaults from over the horizon, staying 20 to 50 miles offshore. Keeping the LHD at this standoff distance drastically increases its survivability, placing it outside the effective range of many coastal defense missiles. Inside the well deck, the launch sequence is a deafening display of power, as the LCAC turbines spool up and the skirt inflates with violent pressure. Once airborne, the craft backs out of the flooded ship, rotates, and sprints toward the horizon, carrying a payload of 75 tons. This payload capacity is specifically calibrated to carry the M1 Abrams main battle tank, the heaviest and most lethal asset in the Marine arsenal. Delivering a main battle tank from a ship at sea to a combat zone in under an hour provides an immediate, heavy, armored punch. The synergy is lethal. While F-35s from the flight deck suppress enemy defenses, LCACs hit the beach with heavy armor to secure the landing zone. Once the beachhead is established, the LCACs switch to a sustainment role, ferrying ammunition, fuel, and reinforcements in a continuous steel loop. Yet, a ship of this value, operating near hostile shores, is a magnet for enemy anti-ship missiles and suicide drone attacks. The proximity to land means threats can appear with little warning, emerging from coastal clutter or hidden mobile launchers in seconds. To survive in this anti-access, area denial environment, the Wasp class is fitted with a layered self-defense suite designed to break enemy kill chains. The defense philosophy is built on depth, engaging threats at long range first, then collapsing into an intense close-range protective bubble. The outer layer of this shield relies on the ship's electronic warfare suite, designed to detect and jam enemy radar frequencies before a missile locks on. If electronic soft kill measures fail, the ship transitions to hard kill kinetics, utilizing the NATO Sea Sparrow missile system. Launchers located on the sponsorship platforms can fire radar-guided missiles to intercept incoming aerial threats miles before they reach the hull. However, the threat landscape has evolved. Modern anti-ship missiles fly faster, lower, and with smarter guidance systems than ever before. To counter low-flying sea skimmers, the ship employs the Rolling Airframe Missile, or RAM, a highly agile interceptor with dual-mode guidance. The RAM system is unique because its launcher rotates to face the threat, firing a missile that spins like a bullet for aerodynamic stability. It tracks the enemy missile's radar emissions initially, then switches to an infrared seeker for terminal guidance, homing in on the heat signature. This fire-and-forget capability allows the system to engage multiple incoming targets simultaneously, saturating the air with defensive interceptors. But in the age of drone swarms and hypersonic weapons, even the most advanced missile systems have a minimum engagement range. For threats that penetrate the missile screen, the final line of defense is the Phalanx Close-In Weapon System, the famous R2D2 of the fleet. The Phalanx is a radar-guided Gatling gun, capable of firing 20mm tungsten penetrators at a rate of 4,500 rounds per minute. It operates autonomously, tracking the incoming projectile and firing a stream of tracers to physically shred the warhead in midair. This wall of lead is a last-ditch effort, automatically engaging any high-speed contact that enters its programmed kill box. Alongside these automated systems, the crewman's 50 caliber machine guns and 25mm chain guns to counter small boat attacks. These manual weapons are crucial defenses against asymmetric threats, such as swarm attacks by fast attack craft or explosive-laden suicide boats. The integration of these sensors and weapons is managed by the ship's self-defense system, a computer network that prioritizes threats in milliseconds. The eyes of this defensive grid are the massive rotating radar arrays mounted high on the island's superstructure, dominating the ship's electronic silhouette. The AN/SPS-48 is a three-dimensional air search radar, mechanically rotating to scan a volume of airspace hundreds of miles in diameter. Working in tandem is the AN/SPQ-9B, a track-while-scan radar specifically tuned to detect the skimming profiles of modern anti-ship cruise missiles. These sensors feed data into the Combat Information Center, a dark, air-conditioned nerve center where tactical decisions are made in seconds. Yet, if a kinetic impact occurs, the ship's survival depends on its internal damage control architecture and the crew's relentless training. The hull is compartmentalized by watertight bulkheads, designed to seal off flooding sections and prevent the ship from capsizing after a torpedo hit. Every sailor on board is a firefighter, trained to navigate smoke-filled corridors to patch hull breaches and battle conflagrations fueled by jet fuel. But the Wasp class is designed for more than just destruction. It possesses a soft power capability that rivals its lethal potential. In the wake of catastrophic natural disasters, tsunamis, earthquakes, or typhoons, this warship transforms into a massive humanitarian platform. The same LCAC hovercraft designed to deliver tanks can be loaded with pallets of food, fresh water, and generators to reach isolated disaster zones. The ship's medical complex is second only to the dedicated hospital ships, boasting 6 operating rooms and an intensive care unit. In a mass casualty event, the facility can expand to handle 600 patients, utilizing the overflow berthing spaces as recovery wards. Crucially, the ship produces its own resources. Massive reverse osmosis plants turn seawater into 200,000 gallons of potable water daily. Line 114. This ability to generate clean water and export it to shore makes the ship a lifeline for populations with shattered infrastructure. This dual-role capability, waging war and sustaining life, makes the amphibious assault ship the most versatile diplomatic tool in the U.S. arsenal. However, the strategic value of the class has shifted dramatically with the introduction of the F-35B Lightning II. Historically, these ships operated Harrier jump jets, which were limited in range, payload, and stealth capabilities compared to carrier-based aircraft. The F-35B erases this gap, bringing 5th-generation stealth, sensor fusion, and supersonic speed to the amphibious fleet. The engineering marvel behind this is the lift fan, a specialized propulsion component located directly behind the cockpit. Driven by a drive shaft from the main engine, the lift fan generates 20,000 pounds of vertical thrust of cold air. Combined with the swiveling rear exhaust nozzle, this allows the 30-ton fighter to hover with the stability of a helicopter. This capability transforms the Wasp class from a mere troop transport into a Lightning carrier, capable of fielding up to 20 F-35Bs. A Lightning carrier can control the airspace over a small nation or sanitize a coastal zone of enemy defenses before the Marines land. This concept of distributed lethality forces enemies to worry about multiple small carriers rather than focusing solely on the large Nimitz class. However, operating 5th-generation fighters exerts extreme physical stress on the ship's flight deck infrastructure. The exhaust from an F-35B in vertical hover is significantly hotter and more high pressure than that of the legacy Harrier jets. Repeated exposure to this thermal intensity can warp standard steel decks and strip away non-skid coatings, rendering the surface unusable. To counter this, modern refits apply a specialized heat-resistant coating called Thermion, a ceramic-metallic hybrid material. Thermion protects the steel substrate from thermal shock, ensuring the deck remains operational even after sustained high-tempo flight operations. Below the deck, the logistical challenge of supporting these jets is equally immense, requiring the storage of specialized munitions and parts. The magazines are deep within the ship, protected by armored bulkheads and complex sprinkler systems to prevent magazine cook-off. Weapons elevators, separate from the aircraft elevators, transport laser-guided bombs and air-to-air missiles from the magazines to the assembly areas. Here, aviation ordnancemen assemble the weapons, fusing warheads to guidance kits with surgical precision before loading them onto the aircraft. Fuel management is another critical engineering constraint. The ship carries roughly 2 million gallons of JP5 aviation fuel. This fuel is constantly filtered and tested for purity, as even microscopic water contamination can cause a flameout in a high-performance jet engine. The fuel system is distributed across multiple tanks to aid in ballast control, shifting weight as fuel is consumed to keep the ship level. All these systems, aviation, amphibious, and medical, require a massive crew to operate, numbering over 1,000 sailors. When the marine component is embarked, the population swells to nearly 3,000, creating the density of a small, crowded city. Logistics officers must calculate the daily caloric burn, loading enough food to sustain this population for months without resupply. The galleys operate 24 hours a day, serving 4 meals daily to accommodate the shifting watch schedules of the crew. Waste management on this scale is a complex industrial process. Nothing is thrown overboard that could compromise the ship's stealth or environment. Plastics are shredded and melted into solid discs for storage, while paper and food waste are pulped and processed. This self-contained ecosystem requires rigid discipline. A single outbreak of illness can cripple the ship's operational readiness in days. Therefore, sanitation standards are clinical, with constant cleaning rotations and air filtration systems running at maximum capacity. The psychological toll of this environment is a design factor. Spaces are painted in soothing colors to mitigate the stress of confinement. Yet, the primary purpose remains violence. Every corridor and hatch is designed to facilitate the rapid movement of men to battle stations. In a general quarters scenario, the ship locks down, setting material condition zebra to isolate every compartment for maximum survivability. Ventilation is shut down to prevent the spread of smoke or chemical agents, and the ship becomes a sealed, fighting tomb. It is in these moments that the engineering proves its worth, keeping the lights on and the guns firing while the hull takes punishment. The redundancy of systems, power, water, data, ensures that the ship can fight hurt, maintaining its place in the kill chain. This resilience highlights the fundamental truth of naval architecture. A ship is only as effective as the crew that bleeds to keep it afloat. The human factor remains the unquantifiable variable in the equation of war, where training and discipline override fear in the face of incoming fire. Leadership on the Wasp class is not merely administrative. It is the burden of managing a floating city that is constantly preparing for its own destruction. The captain must balance the aggressive tactical demands of the Marine colonel with the safety parameters of the ship's engineering plant. This friction between getting the Marines to the beach and keeping the ship floating is the dynamic tension that drives daily operations. Yet, looking at the balance sheet, the amphibious assault ship offers a staggering return on investment compared to the nuclear supercarrier. While a Ford-class carrier costs $13 billion, a Wasp-class hull comes in at roughly 1/5 of that price tag. For the cost of one supercarrier, the Navy can deploy an entire amphibious-ready group, dispersing firepower across a wider geographic area. This economic reality is driving the future of fleet design, pushing the Navy towards smaller, more numerous platforms rather than a few massive targets. The evolution of this class is already underway with the introduction of the America class, LHA, the direct successor to the Wasp. The first 2 ships of the America class made a controversial design choice. They eliminated the well deck entirely to maximize aviation capacity. By removing the ability to launch hovercraft, these ships gained massive internal volume for jet fuel and aircraft maintenance. This design shift effectively created a dedicated light aircraft carrier, prioritizing air dominance over the traditional amphibious beach assault. However, the strategic pendulum has swung back. The Navy realized that giving up the well deck limited the ship's tactical flexibility. Subsequent ships in the America class are reintroducing the well deck, proving that the ability to put boots on the ground remains indispensable. In the context of great power competition in the Pacific, these ships are the linchpin of the Expeditionary Advanced Base Operations Doctrine. This strategy envisions Marines seizing small islands to set up anti-ship missile batteries, creating a kill web that denies the ocean to the enemy. The amphibious ship acts as the mobile lily pad, hopping forces from island to island to keep the enemy guessing and off balance. Unlike a static land base that can be targeted with ballistic missiles, the ship is a moving target, constantly changing its position in the battle space. While critics argue that large surface ships are obsolete in the age of hypersonic missiles, the reality is more nuanced. A ship that can move 500 miles in a single day forces the enemy to dedicate vast resources just to locate and track it. Furthermore, the mere presence of an LHD off a coastline sends a diplomatic signal that is impossible to ignore. It is a visible manifestation of national will, a 40,000-ton statement that the United States has an interest in the region. Air power from a distant carrier is abstract and fleeting. A Marine expeditionary unit parked in your harbor is concrete and persistent. The Wasp class bridges the gap between the subtle threat of a submarine and the overt aggression of a carrier strike group. It is the multi-tool of geopolitics, capable of shifting from a hand of friendship to a clenched fist in a matter of hours. As drone technology advances, we will likely see these ships evolving into motherships for unmanned aerial and surface systems. Imagine a future where the well deck launches autonomous submarine hunters, while the flight deck deploys swarms of loitering munitions. This modularity ensures that the hull design will remain relevant for decades, adapting to new technologies as they emerge. The engineering behind the Wasp class is not just about steel and steam. It is about building a platform that can absorb the uncertainty of the future. From the steam turbines deep in the hull to the radar arrays scanning the horizon, every system is integrated for a singular purpose. That purpose is to project power where it is unwanted, to deliver aid where it is needed, and to hold ground where it matters. It is a reminder that in a world of cyber warfare and long-range missiles, geography still dictates the terms of engagement. You cannot hack a coastline, and you cannot occupy a capital city with an algorithm. Eventually, you have to cross the water. The amphibious assault ship is the engineering solution to that geographical problem, a bridge of steel built to cross the wildest oceans. It stands as a testament to the logistical might of the industrial base that created it, and the sailors who operate it. While it may lack the fame of the Enterprise or the Nimitz, the Wasp class is the workhorse of the modern fleet. It does the dirty, dangerous work of littoral warfare, operating in the chaotic friction points where empires collide. So, the next time you see this silhouette on the horizon, do not mistake it for a mini aircraft carrier. Understand it for what it truly is, a self-contained instrument of national policy, carrying the stick and the carrot in equal measure. In the complex calculus of modern warfare, the ability to be everywhere and do everything is the ultimate strategic advantage. The Wasp class delivers this advantage, proving that sometimes the most dangerous weapon isn't the one that flies the fastest. It is the one that can bring an army to your doorstep and sustain it there until the mission is complete. This is the engineering of invasion, a masterpiece of logistical integration designed to turn the ocean into a highway. As global tensions rise and coastlines become the new front lines, these ships will only grow in importance. They are the vanguards of the fleet, the first to arrive and the last to leave, defining the very nature of expeditionary power. Until teleportation renders geography obsolete, the Wasp-class amphibious assault ship will remain the master of the littorals. It is a floating paradox, a vessel of war built to keep the peace, and a machine of destruction that saves lives. This is the Wasp class, the unsung titan of the United States Navy, engineered for the storm, whatever form it may take. Ending screen with channel logo.